Great. Hello and welcome to everyone. We are, as you all know, at the end of the second part of the QIran Summer School Program, Quantum Game. For this part, we consider two special speeches. We have the first one today and the next one on Sunday. Today, we are honored to host Dr. Oxana Mishina as our guest speaker, presenting a talk titled Photon for a Day. Dr. Oxana Mishina is a distinguished physicist with expertise in quantum physics and education. She earned her PhD at St. Petersburg Polytechnic University Model Quantum Experiment at Niels Bohr Institute and Castor Brussels Laboratory, and developed a theory for cooling and squeezing atom at Saarland University. Currently, she works at Italian National Institute of Optics within European Quantum Flagship, focusing on education and equity, diversity, and inclusion. Dr. Mishina is also an experienced science communicator, actively promoting quantum science throughout educational experiment and outreach events since 2015. Okay, Dr. Mishina, we are here to start your presentation. Yeah.
Thank you very much for such a great presentation and such a deep and extended one. I'm extremely happy to be invited here, and it's a great honor for me to speak at the QIran. And I would like to let's say kindly ask you also to extend a little bit my horizon. So I will now greet you in Russian, and you will now greet me in your language, if you don't mind, okay?
Yes, yes. Okay.
Okay, so I start greeting in Russian. Здравствуйте. And now it's your turn.
I don't know Russian.
No, in your language, in your language.
Please again.
So I say здравствуйте, приятно познакомиться.
In Persian, it's a kind of greeting.
Yes, it is like, hi, it is nice to meet you.
سلام، خیلی خوشحالم از دیدنتون. Nice to meet you. In Persian.
Thank you so much. Thank you so much. Okay, now I will turn on my slides and hope it will all work. There will be a little video, so I should share sound. Do you see my slides now?
Yes, yes. All clear.
Okay, very nice. So there's somebody who wants to be admitted. I think he'll take care of that.
Yeah,
and so today I will present you this game, which I hope it's a game, but I think it's more an experiment. It's a social experiment more than a game or an acting game. And this experiment, I hear some voices. Maybe you'd like to switch your microphones. And
I will mute, yeah.
Okay.
Okay.
Oh, sorry. So I went too far. So this game, this idea came into my mind when I was preparing for an event here in Trieste that is called a Mini Maker Fair. Oh yeah, I hear a lot of voices. I'm sorry, but this is disturbing.
Let me, yeah.
Could you please mute everybody?
Yeah.
Okay, I think I can mute you as well. I did it. So in this Maker Fair, it's a worldwide event, and usually people present something they made. And as I'm a theoretician and I can hardly make any experiment, I usually present talks and lectures, but I was tired of it, and I thought that I want to create an experiment which will allow like a full body immersion. And this is what you will see here. And so I'm from National Institute of Optics, CNR-INO, in Trieste, in Italy. And recently my Solarly team was joined by Shaima Zaman, I'm sorry for the typo, Ahmed, and she is a founder and a CEO of Science Melting Pot in Aarhus in Denmark. And she is also a physicist and a doctor in physics, and now she's dedicating all her efforts into science communication and inclusion in our society. So first of all, just a few words, if it works. It doesn't. Okay, now it works. Just a few words about the quantum flagship, which you have probably heard about, but in case you didn't, you can explore it very much in the qt.eu website, and I will just show you the introductory video. Okay, so I hope that you have heard also, not only seen the video. And this is just to say that for 10 years, the Europe has invested 1 billion euros into pushing technologies from the laboratories to the market. And we are 5 years through, and it has been going really, really nice because there are a lot of startups. There are few computers built up in Europe, and a communication scheme of the quantum internet starting to be built, and a lot of great sensors have been put into the start of the production chain. So I think it's a very exciting period now, and you are of course already making change for it because you're here and you're interested in quantum. And we know that the biggest bottleneck in quantum is the quantum technology workforce. So people who would like to build it and who would like to explore it and to research about it and to find new solutions. So for that reason, Quantum Flagship has created the Qt Edu Coordination and Support project. And I was part of the team of this Qt Edu, and we created the Qt Edu community with a lot of people who are interested in teaching, educating, doing outreach, and communicating about this fascinating technology to the world. And so part of my work, of course, belongs to that communication to the world. I presented myself my presentation was already done very nicely, so I skipped that part, and I present Shaima, which I have already spoke about, and you can find both profiles of us on the Qt Edu network, and I welcome you to join this network. This is very easy. You just press get involved button and join the community, and you can find a lot of resources and a lot of people that can have interests that are similar to yours. And Shaima is with us connected, but she wouldn't speak up because she's at the sea with her mom, who is visiting her from India to Denmark, and I hope they're having a great time. Maybe she will send us a heart in the chat. So let's go to the meet. So when I was thinking that I want to do something which is not just a speech, I was dreaming of three things: full body immersion, real lab experiment, so it should be connected to whatever existing or being able to exist real lab experiment, and it would explore the quantum probability, because I believe that in the quantum probability, which is actually the quantum probability amplitude, there is the whole meat of quantum phenomena and possibilities that are not accessible to the classical physics. And so what happened is I came up with this kind of an acting-like experience. I don't call it experiment now that I call it a game. It's an experience, and it is a group activity where minimum 4 persons should participate. And so it reminds a little bit of a collaborative game. Now we are coming to the second point, which is an actual experiment, and I couldn't do less of using one of the most important demonstration in the quantum information, let's say, for the quantum information science, where a single photon passage through the interferometer was observed, and the single photon so-called interference was confirmed. What is a single photon? I will not tell you, okay? This is something which many people don't coincide on. What I will tell you is what we observe when we send a minimum portion of light, less than this, with a given frequency energy, it cannot be. So this is what the quantum of light is. When we threw it through an interferometer that is called the Mach-Zehnder interferometer. Philippe Grangier and Roger and Aspect, so Grangier, Roger and Aspect, in '86, they have decided to do it in the lab. By the way, Philippe Grangier is now a coordinator of the CSA that coordinates quantum flagship. So he's my direct boss, practically, of the big project. So what happens to the single photon, or to this minimum quantity of photon, the photon quantum, when we send it through the beam splitter? So beam splitter is the first thing on this graphic. If you see my mouse, do you see my mouse? Do you hear me?
Yes, yes.
Okay. Do you see my mouse?
Yes, yes, I see your mouse.
Okay. So this is the input of the quantum. This is the first mirror. By the way, can I ask you, raise up your hand if you know what is Mach-Zehnder interferometer? Okay, no hands, which means that it's good that I have this. Yes, this is the reply if you know about Mach-Zehnder interferometer, I hope. I'll write your questions here. It's okay, probably not. Okay, so you send it through the beam splitter. What beam splitter does to a lot of light, it splits it into two parts. So half of the light goes straight and half of the light reflects and go up. And so practically what happens is that we expect this quantum of light to or pass through or go up or to divide. But if to divide, it means that it is not a minimum quantum, okay? So what they observed first is that here they saw a click, and also here they saw a click once sometimes. So they had registered light in both arms. Now the question was, do they register simultaneously in both arms or always separately? Okay, and so they put two other mirrors. They put two other mirrors to like reflect these two light beams and put them again, these paths, and put them again to the beam splitter. Okay, and through this beam splitter, the light could go through again like this, or to reflect and get to another detector. So practically here, the game would be, so if the light would come up from both directions at the same time, you will get a click here and here. And if the light would come out only from one at a time, you would get a click only here or only here at a time. So practically it's a coincidence experiment. You get the photons here and you try to see the coincidence between them, if they come at the same time or not. Okay, the result of this experiment, I tell you immediately that they did not see a coincidence. So it was a drop in the coincidence when they aligned well the interferometer. Practically, usually it's really hard to get the interferometer equal. It's much easier to get it unequal. And so when they got it aligned well, practically you did not get coincidence. And this means that photons was always coming from the same side. And interestingly, it was always the same side, this one, for example. So this is a result that tells you that a single portion of light exists, first of all, because there is no coincidence. And so you send a single one and it does not divide. And the other one says that, why do they always come here? Because they could pass either this way or this way. They could come out or here, this photon, but not, it only comes out here. So two things. And practically, in fact, it illustrates that while passing the two equal ways, the probability to pass two equal ways, the probability amplitude interferes here. And it turns out that it goes to 0 when you look at the output in the top, and it goes to 1 when you go at the output through. Okay, so that's an experiment. They did it. It's true. We confirmed the quantum interference of a single particle, that a single particle somehow distributes between two paths. Weird, huh? It's enough weird, but they confirmed it. And this is what I created with my boxes from, it's empty boxes from the Food for Cats that I took from my friend. And I added to them some arrows so that this is the beam splitter when you enter to the interferometer. And you choose to go right or left.
Amore mio.
I'm speaking Italian here because it's an Italian festival. And so this person was playing perfectly the photon because she was like deciding where to go. Then she reflects from the mirror and there is a second beam splitter and she could decide to go through or to reflect. She would reflect down because I reoriented my interferometer. And so she came through to join me. And in this way, many people did the same thing. And of course, when they did it randomly one by one, it was like a natural result. They came out either from one side or from the other side. And this is something that photons could never do. So my trick to them was to say, what can we do that photons cannot, which is a little bit like a playful idea. Okay, and now I will tell you, I will show you how I made them. Oh, then I did a little quiz, but this wasn't very successful, so I'm not doing them anymore. And so this is the key part of the quantum experiment. I still have 5 minutes, so I will speed up. So I did 4 of these things. I drew them. They should look like a photon, although it looks more like an S. So I drew them, and you could rotate them. Each one you could rotate in its reference frame remains 0 and 180 degrees. And practically when you go on one arm, you reflect, you rotate. If you go straight, you don't rotate. So if you turn, you rotate. If you go straight, you don't rotate. So you rotate in one arm, you don't rotate in the other one. Then you reflect in the other arm, you don't rotate rotate in the second one. And so practically you just do what you have to do. And in the end, you put together on both outputs these 2 papers on one outputs and 2 on the other. And you see that on the left, you see the S, which is beautiful. It's turned around, but it's the S, the F for me. And then the other one, they compensate each other, which should illustrate the negative interference. So 0, there is no light that is coming there. And this was the experiment that I created, and 4 people could do it. Okay, so I played this experiment 2 times already in Trieste, and it always was great fun, and I'm trying different techniques. So the last one was I just give them the paper and I say, you have to come out of the same side, and then they have to find out the rule. So I'm trying to experiment with this, and it's always interesting and different. And if you like it and you would like to suggest some ideas or try it, just send me an email and we will figure it out. Thanks a lot. I'm done, and I would be happy if you ask me a question.
Thank you, Doctor. If anyone has question, can unmute and ask their questions. Oh. I have a question. I would like to know how, for example, we are in QIran now. We are in Iran, and how we can join to quantum flagship. Is it any possible to join?
Quantum flagship.
Yeah,
Okay,
European
so
quantum flagship.
let me say you the following. First of all, you're very welcome to join the QT Edu community, which is a community that is closest to the flagship, that is a quantum flagship education community. And this is open to the whole world. It was created in Europe, but we are not, we don't have limitations. So this you can join right away. Then you are very welcome. There is an interesting event now, and it's a yearly event. It's called EQTC. It is the European Quantum Technology Conference. And the next one will be in October. And the QIran can easily get a, so there wouldn't be, I'm sure there wouldn't be a problem. And if you wish, I could also try to get some kind of a corporate discount for you, and maybe as an education, even have some special deal for you if you wish to come. It's far away. I understand that from Iran, it's not very easy. And so this is the other way. And EQTC, so in European Quantum Technology Conference. Then we also have in the community, in the QT Edu community, which will restart the tradition of the education, well, it's called tools, tool demos. So we were demonstrating various education tools to the community. And in fact, not only tools, but also networks and interesting initiatives can be demonstrated. And so you could also be give a presentation of how you do things in Iran. So this for us would be very, very interesting. So you just email me and let me know that you are interested in making such a sharing, and we could make a community meeting special for you.
Yeah, because in QIran, we are active in education through universities and high schools, and we want to have a kind of working group active in designing educational tools. For example,
that's
game,
fantastic.
game is the best way. And I would like if there is any opportunity to contribute with and with Quantum Flagship and have a kind of support from this institute. Yeah.
You know what you can do? There is a very, very big initiative that Quantum Flagship is supporting greatly. It's called World Quantum Day.
Yeah.
It's 14th of August.
Yes.
You know about it?
Yeah, the Quantum Day. Yeah.
World Quantum Day. So what we do in Italy, and you could also do in Iran, we do something that is called Italian Quantum Weeks. For a few weeks, each city of Italy organizes some local activities. There are games, there are seminars, there are even exhibitions sometimes.
Different activities.
And so we have already a lot of materials prepared and exhibitions and so on. And we would be super happy to share if you wish to do such a thing, such a network of activities in Iran. We would be in Italy greatly happy to connect with you and give you all we know, all our experience, and help you how we did it. And so you could do this in Iran, and Quantum Flagship supports all these kinds of activity very, very largely. So they will give you visibility. You can also submit in the World Quantum Day all your activities and so on. So that would be another way.
Great. Thank you.
And keep in mind that 2025, which is in 2 years, will be the International Year of Quantum Science and Technology. UNESCO is just about to proclaim it, so it's not yet official, but this is how it's gonna work.
Great. We have some questions in chat box. Yeah.
Okay, so I'm looking at it. Just a sec. From the experiment shown, I could deduce the particle character of photons. Okay, the wave character remained elusive despite the interference. So it doesn't get to be demonstrated in the results. Okay, I really love these questions. Thank you very much.
Mohammad Reza. Yeah, Mohammad Reza.
Yeah. Thank you so much. This is a wonderful question because this kind of duality, so that is what they teach us in school, and they teach it to us in university, and they just I say they as if I am not part of them, And it is because I'm changing my religion from this point of view, because in the theoretical framework of quantum physics, which is the current state of the art of physics, it is very inefficient to use this duality language. It is much more efficient to use the language of superposition and the language of observables and quantum probability distribution, so amplitude, probability amplitude. Why? Because of this exact word that Muhammad Reza wrote, elusive. So it gives a lot of illusion when you expect something of duality, when you expect a particle or you expect a wave. And people always expect, this is normal from us, because if we prepare experiment, we had our hypothesis to prove. And this elusiveness gives a lot of discomfort to many people. So after many years in this field, I have observed that this is just a turbulence that is unnecessary. So the point is, what we call particle-like behavior is when we have a click, okay? And this is what was obvious to you, and many times, okay? So what we call wave behavior, which is something that wave can do that particles can't. And this is interference, which you have also mentioned. So in this experiment, of course, we remain getting clicks, okay? So what is interference in this experiment is no click, okay? So in this experiment, no click at one outside is the sign of interference, because if there wouldn't be an interference, there would be clicks in both sides. But it's too little, I agree with you. It's too little to even think about it. So I have to explain it to you in extra 5 minutes, and then you understand. But if you do like quickly, it seems like, oh, but so photon is not a particle. Where is this interference? And this is a strange thing. So yes, this is why I think this language has to be abandoned. So we have to think about superpositions and results in observation. So when we say that superposition is being on one pass and on the other pass, and being outside on one input output and on the other output, then immediately you understand that something is missing, okay? And you don't think about the wave pattern, okay? So you don't think about something that is wavy, because there is nothing that is waving. It's called probability amplitude, which is the wave part amplitude, just because we could not find any other word. So the language problem in quantum mechanics will never go away, because our language is from our everyday observation, and it's classical language. So we need to clip-clop classical language to classical language to get a little bit to the outside of classical, and this will be elusive further on. So we will not get out of illusions, we can just get more or less of it. So I hope my answer helped you, but I totally understand your turbulence. So thanks a lot for the question.
Thank you. Any questions?
No, he says thank me, so he means that probably it gets there.
Okay.
While you are preparing the questions, if you still want to prepare them, can I ask you all unmute and greet me in your language? It's just that I'm so far from you, so I would like to get as much as possible interaction. So if you all unmute, and if you don't mind, also open your video. Probably no, because we are in registering, no? So people would not like to open the video. But at least unmute and say, hi, Oxana, in your native language, because I don't know if all of you are speaking Persian. Maybe somebody is from other language group.
I think it's better to have a kind of group photo. Take your photo.
Wow. This would be even more interesting.
Please.
So
لطفاً بچه‌ها دوربیناتون رو میتونید باز کنید که ما بتونیم یه عکس دست جمعی هم بگیریم. I say to all, open the video and have a take photo.
Откройте свои камеры, и мы сделаем фотографию. If somebody will watch in Russian, that's just double. I like to give all these kind of things to my family, but they don't know neither English, no Persian, so no way.
بچه‌ها اگر دوست دارید که دوربیناتون رو روشن کنید، یعنی فعال کنید که ما بتونیم یک عکس دست جمعی با هم دیگه بگیریم.
Okay, we have Farshid. Hi Farshid.
They are shy. Little shy.
How do you say hi in Persian?
سلام.
Halom.
Halom. In
Alom.
Persian, we say salam.
Salom. Okay, salam.
Salam. Yes, salam.
Salam, salam Mali.
Salam,
Mali, yeah?
salam.
Mali, yeah.
Mali, yes.
Salam. That's so
Salam.
nice.
They are a little shy. Okay.
Yeah, I think it's not good to force everybody, but
Yes,
it's
yes.
already good we are in four. So we can say hi as a great
Yeah.
teacher.
I really thank you for accepting our invitation for these great speeches and all who participate in this event. Thank you, Doctor.
Bye bye.
ممنون.
Have a great day. Bye.
You too. Bye.
Thank you, thank you. Thank you all for participating in this talk. Thank you. Have a great day.